Hello, you guys. Let's talk about Chapter 9, Lesson 1, Square Roots. Okay, first thing, notice what I wrote in the margin. You are going to have to memorize the perfect squares all the way to 20 times 20 is 400, okay? So, the square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. The square root of 81 is 9. Square root of 100 is 10. Those are the easy ones. You probably already know those. Square root of 121 is 11. Square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. The square root of 225 is 15. The square root of 256 is 16. The square root of 289 is 17. Square root of 324 is 18. Square root of 361 is 19. And the square root of 400 is 20. So I want you to memorize those. Okay, well, let's talk about what is a square root. So if I ask you for the square root of 16, you would tell me it's 4. And I think a visual picture is kind of nice to look at. If I drew a square and I broke it into 16 equal pieces, so the area was 16, you know that each of the edges would be 4. Well, the square root just represents one of the edges of a square. Okay, and perfect squares we've already talked about. Here's a list, and they're in your margin as well. And then a radical expression just means that it has a square root. So for example, the square root of 3a is a radical expression, because another word for square root is radical. Or the square root of x minus y is a radical expression. Okay, let's talk about example 1, finding a square root. Here's the situation. A community is building a playground on a square plot of land with an area of 625 square yards. What is the length of each side of the plot of land? So remember, when they're asking what's the length, we want to use a square root because it was a square. So they sketched a square. They told you that the area was 625. Now we just have to find the edge. And so we're basically finding what is the square root of 625. But I want you to notice something. Isn't 625 larger than what I asked you to memorize? I asked you to memorize up to 400, not up to 625. So I'm going to show you a trick with how do we get the square root of these larger numbers. And we're going to spend a whole lesson on it. So this is just an intro to lesson 9.2. But basically what you want to do is take that 625, the number under the square root, and we're going to do a factor tree. Okay, so break it apart. I know 5 goes into it 125 times. And now I circle the 5 because that's prime. And I keep going. I break apart 125 to be 5 times 25. So I circle the prime, the 5, and then I break apart 25 to be 5 times 5. Now watch what I do. What we want to do is pair things up. So I see 1, 2 5s. So notice over here in the margin, I said, okay, the square root of 625 is the same as the square root of 5 to the second power. I just took 2 of them. 5 times 5 is 5 to the second power, times another 5 times 5. Okay, and then I break it apart. The square root of 5 to the second power times the square root of 5 to the second power. Well, you know that the square root of 25 is just 5, and the square root of 25 again is just 5. So 5 times 5 gives me 25. So basically, 25 times 25 equals 625. So if I want to know the square root of 625, it's just the number 25. And again, the reason why, because 25 squared is 625. So I know the length of each side of the square is just 25 yards. Okay, now most of them are not that hard. Most of them are going to be really easy. Look at the checkpoint. They want to find the square roots. Notice the S at the end. That means that there are actually 2 answers to these, a positive and a negative. So you know the square root of 9 is just 3. But it could also be negative 3, because negative 3 times another negative 3 would make a positive 9. Okay, so the square root of 49 is 7, but it could also be negative 7. And I only give them both answers when they want the square roots, plural, with an S. Okay, the square root of 169 is just 13, or you could say negative 13. The square root of 196 is 14, or you could say negative 14. Okay, let's talk about example 2, approximating a square root. So we're just going to say, it's about, okay, we're approximating. So what if I want to approximate the square root of 28 to the nearest integer? That means the nearest whole complete number. So the perfect square is close to but less than 25, right? So 28 is close to 25. And the perfect square closest to but bigger than 28 is 36. So 28 is between 25 and 36. And so we write it as a compound inequality. That just means we would say 25 is smaller than 28, which is smaller than 36. So you're just putting the numbers in order. Now, 25 is a perfect square, and 36 is a perfect square. All right, and so now we just take the square root of everything. So the square root of 25 has to be smaller than the square root of 28, which is smaller than the square root of 36. So then we just exchange. The square root of 25 is the same as the number 5, and that's smaller than the square root of 28, which is smaller than 6. So we know the square root of 28 is between 5 and 6. Now, to decide which one it's closer to, back up to right here. Notice how 25 is really close to 28. And so it's only 3 steps away. Here, 28 and 36, they're 8 steps away. So these two are closer. So when you're asked to round to the nearest whole complete number, you would have to say that because 28 is closer to 25, then the square root of 28 is closer to 5 than it is to 6. So the way that we write it is we just say the square root of 28 is about, use the wavy equal sign, 5. Okay, so go over the checkpoint with me, and remember that directions say approximate to the nearest integer. So let's say I want to approximate the square root of 46. Well, I find the two closest perfect squares to 46, and that would be 36 is a little smaller, and 49 is a little bit bigger. And then I take the square root of everything. So the square root of 36 is the smallest, then the square root of 46 is in the middle, and then the square root of 49 is biggest. So then I just replace the square root of 36 as the number 6, so I know 6 is less than the square root of 46, which is less than 7. And now I just say, well, which one is it closer to? And I always like to use this step right here. Notice how 36 and 46 are about 10 steps away. But 46 and 49 are only 3 steps away, so these guys are closer. So you would say the square root of 46 is about 7. Okay, take a look at number 6, and notice this negative in front. So now we're going to be dealing with negative values. So this means the opposite of the square root of 125. Well, I know that 125 is between two perfect squares, 144 and 121. But notice because of the negative, I had to put this one first. Negative radical 144, let me say that so you get used to that, is smaller than negative radical 121. And so I would know that the negative radical 144 is negative 12. And then I say is less than, then I bring down the negative square root of 125 is less than, and then I replace negative radical 121 as negative 11. So I know it's between negative 12 and negative 11. I just need to see which one it's closer to. Well, notice here, 125 and 121 are only 4 steps away from each other, so they're really close. So I would say the opposite of, or negative radical 125, is about negative 11. Okay, take a look at number 7. When they give you these crazy decimals like the square root of 68.9, just round it, because we are just rounding. So 68.9 is about 69. So let's just use that to estimate. So then I would say the square root of 69 is between the square root of 64 and the square root of 81. So it has to be between 8 and 9. Well, it's closer to 64 than it is to 81. So it's closer to 8. So the square root of 69 is about 8. Okay, here, same thing. See the negative, I'm going to keep the negative in front, but 87.5, I'm going to round to about 88. So I just have to estimate negative radical 88. Well, I know 88 is between 100 and 81, and so it's got to be between negative 10 and negative 9. Well, it's closer to the 81, so I'm going to say that the opposite of the square root of 88 is about -9. Okay, so look at this checkpoint. I want you to cross out use a calculator. You can't use a calculator. I'm sorry. Not on the state exam and not on the algebra readiness exam. So no calculators. We're just going to approximate the square root. And we're also not going to round to the nearest tenths. We're just going to round to the nearest whole complete number or integer. Okay, take a look at number 9. The square root of 6. So I look for the two closest perfect squares. So that would be 4 and 9. And then I take the square root. So the square root of 6 is between the square root of 4 and the square root of 9, which means it's between 2 and 3. And notice, between 6 is 2 away from 4, but 6 is 3 away from 9. So it's a little bit closer to the 4. So that means the square root of 6 is closer to 2, so it's about 2. And then take a look at this one, the opposite of the square root of 104. So I just look for the two closest perfect squares, which would be 121 and 100. And because of the negative, I have to put the negative radical 121 first. So I know it's between -11 and -10. Well, it's only 4 steps away. 104 is only 4 steps away from 100. So that means it's closer to the -10. So I'd say negative radical 104 is about -10. Okay, take a look at example 4. Now we're just getting into evaluating. But I want to go back to order of operations. And when you do the stair steps again here. And remember, we have to take care of grouping symbols first. Well, isn't this cool? The square root, or the radical, is a grouping symbol. We're going to treat it just like parentheses. So we have to do what's under the square root first. Then we're going to do exponents. Then we're going to take care of multiplying or dividing from left to right. And then the last thing we do is add or subtract. So take a look at this. Evaluate 5 times the square root of a squared minus b when a is 6 and b is 27. So the first thing we do is we plug in the values. So I plugged in a 6 for the a and a 27 for the b. And now remember, you have to look under the radical. You have to do that first. So I have a power, an exponent, and I have subtracting. Well, you know you have to do the exponent first. So 6 to the second power is 36, and then I just brought down the minus 27. Well, I still have to do what's under the square root, okay? So that's 36 minus 27 would give me 9. And so I have 5 times the square root of 9. Well, I'm just going to finish this. The square root of 9 is just 3. So it means 5 times 3, which is just 15. Okay, so let's evaluate these expressions when a is 16 and b is 9. So the first thing we do, notice that negative in front, keep the negative in front, is replace the a with a 16 and replace the b with a 9. And remember, the radical is a grouping symbol. You have to do what's under the radical first. So I'm adding 16 plus 9 to get 25. So this is the opposite of the square root of 25. Well, let's replace the square root of 25. We know that's 5, but bring down that negative. So our final answer is just -5. Okay, take a look at 14. I'm going to replace the b with the 9 and the a with the 16. So I have the square root of 9 to the second power minus 2 times 16. Well, I have to do the exponent first, so 9 to the second power is 81. Then I copied the minus 2 times 16. Now I have to do the multiplying next, so I get 81 minus 32. Now I still have to keep going because the radical sign is a grouping symbol. I have to keep going here. So under the radical I have 81 minus 32, which is 49. And then you know the square root of 49 is just 7. Okay, and then take a look at 15. I have 2 times the square root of AB. So I replace the a with the 16 and then put a times and the b with the 9. So I have to do what's underneath the radical first because that's a grouping symbol. So that gives me 144. So I have 2 times the square root of 144. Well, I replace it. I know the square root of 144 is 12. So 2 times 12 gives me an answer of 24.